Okay guys, so I wanted to go over a problem pertaining to three-part definition of continuity, which has to deal with limits. You're going to get a question like this tomorrow, so I'm just using this graph as an example to illustrate what is happening here. This question is asking what is the one value of x at which g of x is discontinuous. So the first part we're going to look at is that we see that this function is discontinuous at x equal to 1. So you see there's a break right there, right? So for number 1, we see that's a break, but we do know one thing. G of x is defined at 1. So g of 1 is defined here. Okay? And g of 1 is also equal to 0. So that's one part of the definition that we know, that it is defined, okay, and it's equal to 0. As you can see right here, this black circle right here. Now, number 2. I'm going to go ahead and scroll this up a little bit here, so I hope I don't lose too much. So number 2, the limit of g of x as x approaches 1 from the left is going to equal to 0, but the limit of g of x as it approaches 1 from the right is equal to 2. So to sum that up, the limit of x approaching 1 from the left of g of x is equal to 0, and the limit of x approaches 1 from the right, g of x, is equal to 2. So right away, as you can see right here, it's not going to exist because I have two different values right there. You see that right there at 2 from the right, coming all the way up down to from the right, and then coming from the left is equal to 0 here. So now that's going to be a huge information for me to say, wait a moment, since the left and the right limit do not equal to each other, then therefore the limit does not exist. So limit as x approaches 1 of g of x is d and e, or does not exist. So then we go to that part. So if we look at this, so since the limit of g of x does not exist and g of x is not continuous at x equal to 1, even though x equal to 1 is on the domain of g of x. So yes, I do have a domain part, but the third part right there is although g of x is, okay, g of 1 is equal to 0, it is still discontinuous. I'm going to put it in short, discontinuous, because the limit does not exist. Okay, so hopefully that's going to be very helpful for you tomorrow. So remember, three-part definitions. Do I have a defined point? Does the left limit equal to the right limit? And therefore, at the very end, if the left limit equals the right limit, is the limit continuous at all? Okay, and that is the main issue. If I do have a continuous point, my graphs should be connected somehow. Okay, all right. So hopefully that helps you guys out for tomorrow.